Hello everyone, Priya Bhatia this side, and I hope you all are doing well. So, until so far, if you remember, in our previous sessions, we have completely covered up the concept of linear regression, right? We have talked about the mathematical intuition, we have talked about the problems that we usually face when we apply that algorithm, right? We have talked about the implementation as well. Now I think here is the time where we shift towards the another important algorithm that we have, which is the logistic regression in machine learning. Although the name seems same, right? Regression word is there, but the task is entirely different. So in this video, we will discuss about at what point of time we should go for logistic regression algorithm at the very first part, and after that, step by step, the format will remain the same in the entire videos. We will first of all discuss the mathematical intuition about this algorithm. After that, you will see that in the upcoming sessions, we will talk about the implementation of the same. So whenever we are talking about logistic regression algorithm, right? It's a classification algorithm. So although regression words seem similar, but basically this algorithm is used to do a classification task. So if you remember, in the very initial videos of machine learning module, I have talked about, right, that either in a supervised machine learning algorithm, we will be focusing on the regression problem, or we will be focusing on the classification problem. So let me again give you a brief overview, and with that story, we will start our today's discussion. So let's say I will give you a very simple example. For example, there is a use case where you will be having a healthcare data. Okay? You will be having a healthcare data. And the use case seems like that, uh, obviously you will be having a patient's features. Maybe you will be having what is the BP level of patient, what is the BMI level of patient, whether a patient is pregnant or not, and many more features, right? And many more. So I have given you one simple example. Now, the task is to predict, depending upon these features, that a person or a lady specifically we are talking about is diabetic or not. So either the answer will be 0 or the answer will be 1. 0 indicates that the person or that lady is not diabetic, right? Not diabetic. And 1 indicates that she is diabetic. She is diabetic. It's a simple classification problem, right? And this kind of classification problem you will call it as a binary classification problem, because in this case you can clearly observe we have two classes. Binary classification problem. Why it is called as a binary classification? Because again I am repeating, we are dealing with the two classes. Two separate classes are there, 0 and 1. There are two separate categories which is available. So what will happen is, with respect to this data which we are talking about, we will be having feature F1, we will be having feature F2. So feature F1, feature F2, feature F3, feature F4. Let's say we will be having 9 features, right? And this 9th feature is a target value, which is a target value, or you can say is an outcome value. By the way, this particular data set, you will be easily able to find it on the web also. You can just refer diabetes data. Open source data is available, in which you will observe there are 8 particular features we have, and the last one is a target column that we have, right? So what is the target indicates? It is indicating either the value as 0 or the value as 1, means corresponding to every particular numeric data that you have, every particular patient record that you have, a label is there. And that label is either 0 or it will be either 1, depending upon what kind of values we have in all those features. So either the patient is diabetic or the patient is not diabetic, depending upon the features. This kind of problem is called as a classification problem. Now you can ask me, Priya, does we have only binary classification problem? No, in future you will see that we will be able to deal with a multi-class classification problem also, where we will be having, let's say, 3 classes, maybe 0, 1, 2, or we will be having, let's say, 4 classes, 0, 1, 2, 3. So this kind of problem can also be solved via the logistic regression, or in future also we have so many different algorithms which we will discuss in our complete module of machine learning, that we do have different other classification algorithms as well. But yes, there exists the problems of multi-class classification part per se as well. Okay? So don't consider that we have only binary classification problem. In a real time, we can have a multi-class classification problem as well, depending upon what kind of use case and what kind of data set you are dealing with. Okay? So this is how the concept will look like. Specifically, you will observe logistic regression works best in a binary classification task. Although there is a concept of multi-class classification as well in a logistic regression, but usually the performance is not that much good as comparable to other algorithms that we have for the classification task, that you will observe when we will do the practical implementation as well. But as of now, you can take a note somewhere that in a binary classification task specifically, logistic regression works well, but it will not work well in maximum scenarios, in maximum use cases for the multi-class classification algorithm. And that's where we usually go for other classification algorithms that we have in machine learning. Okay? Now the question is, how will it work? So I hope that you are already aware about the working internal intuition behind the linear regression algorithm. So what we are doing in that linear regression algorithm, so if you remember, we are trying to find the best fit line. So let's say we will be having a data point, and what we were trying to do is, depending upon the data, we are trying to find out the best fit line which is holding all the data points that we have in such a way that we will be able to have a minimum error, minimum value, minimum error. That is what we are looking for. But now the problem statement is entirely different. Here we don't want to predict some continuous number. We want to predict a class. So let's say what I want to do here is, I will be having a data points. I will be having a data points, right? But we will be having the classes. Let's say we will be having 2 classes. And again, I want to find out somehow the best fit line itself. But let's say one class belongs to 0, 0, 0, 0 value. Another class belongs to, let's say, 1, 1, 1 value, right? So maybe 1 is the class which belongs to a person who are diabetic 1, 0 belongs to a class which are non-diabetic 1. So somehow in both the cases, we're trying to get that best fit line itself, that if let's say in future some new data point will come, so if that value is 1, it will directly go to this class, or if that value belongs to 0, it will directly go to the another class. But the question is that how is it possible? How we will be able to find out in logistic regression case this best fit line? So the situation is different, but the internal intuition is same, right? The only thing here in logistic regression is that we are looking for a probability part per se, right? So basically what we want is, we want that if let's say someone is giving me a data set, I will tell to them that, okay, what is the probability of that particular patient having class belonging to class 0? What is that probability? And what is the probability of patient belonging to class 1? So what I want is, internally my algorithm or my model will try to find out some probability, and whichever is having a, let's say, higher probability, that particular class it will belong to. For example, let's say they will be having a probability of 0.45 here, and obviously if the probability of 0 is 0.45, so you can say it will be 0.55, right? So automatically you will say that person belongs to a class 1, means they will belongs to a diabetic class, right? So basically that is what we are looking for, where we are trying to find out the probability of a patient. Now, because we are looking for a probability part per se, there exists some interesting function in logistic regression which we call as a sigmoid function, which actually works internally in the logistic regression. This function provides the probability of individual class that we are looking for. So how will this look like? I hope that you guys are aware about this function in mathematics, but if not, let me just share with you a picture of this particular function. Okay? So let's see this particular sigmoid function which we are talking about. So I hope that picture is visible to everyone. So here you can see this is the definition of a sigmoid function, right? So usually we are trying to find out y cap is nothing but is equals to mx plus c is the best fit line, right? But in this case, because I'm not looking for a direct number, real valued number, I'm looking for a probability. So what I will do is, on top of this function, on top of this straight line value, I will try to apply a sigmoid function so that I will be able to get the probability. Now, how your sigmoid function will look like? It can also be represented by the sigma of y cap. You will say it will be equation is 1 upon 1 plus e to the power minus of y cap. That is how your sigmoid function will look like, and it will be able to give you the probability of that particular data that you have. And according to that probability, you will try to find out that whether it belongs to class 0 or class 1. Now you can see in this threshold, right, there is something called as 0.5. So by default, 0.5 is the threshold, and what this graph is indicating, this sigmoid function graph, that if the probability is less than 0.5, if for any class the probability is less than 0.5, so definitely you can mark them as 0. If it is bigger than 0.5, you can mark them as 1. That is how the complete picture will look like, right? So basically what we will do here, we will try to solve this equation. You will be able to see, just try to apply the value of y cap, 1 plus e to the power minus of mx plus c, right? This can be written as 1 divided by 1 plus 1 divided by e to the power mx plus c. So what you can do is, you can just try to take a LCM and you will be able to see e to the power mx plus c will come up, and it will be 1 plus e to the power mx plus c. And this is the value you will be able to get. This is the value you will be able to get. Sigmoid function of y cap, right? Now, what you can do is, you can also try to find out 1 minus sigmoid function of y cap. Why? Because let's say this is the probability of one class. Let's say this is the probability of class, let's say A, or maybe let's say class 0. So obviously the class 1 probability is 1 minus that particular value, right? Do you agree with me? Because you know that the addition of all the probabilities will always be equals to 1. And because we are as of now dealing with a binary classification per se, so we will be having two classes specifically. Binary classification per se, we will be having two classes specifically. So one is the probability of class 0, and another probability is the probability of class 1, which will be equals to 1 minus the above probability. So if you will try to solve this equation, mx plus c, 1 plus e to the power mx plus c, you can solve this equation by taking again a LCM, 1 plus e to the power mx plus c, 1 plus e to the power mx plus c minus this will come out to be this. So what you can observe here is that in a way, this is the equation number 1 which we are getting, and this is the equation number 2 which we are getting. If you will try to divide both of these equations, sigma of y cap divided by 1 minus sigma of y cap, it will be equals to, what is the value you will be able to get? E to the power mx plus c. Can I say, everyone? It's a simple maths which I am trying to do, nothing big, right? Because the denominator is same. So if denominator is same, they will cancel out with each other. So this is the value we will be able to get. So when we apply log base e on both sides, this is a kind of a equation which you will be able to get. 1 minus sigma of y cap, and here this power value will come up front. You will be able to see mx plus c, and then you are applying log base e value e. Both of them will mark as 1. So what is the equation you will be able to get? Log base e sigma of y cap 1 minus sigma of y cap mx plus c. So this is the kind of the equation which you will be able to get in a logistic regression, right? So here if you will be able to see, now what is happening is, let's say I am saying that the probability of class 0 is 0.2. Probability of class 1 will be automatically 1 minus 0.2, which will be 0.8. So if you will try to apply this equation, if you will try to apply the value on this equation, you will be able to get log base e 0.2 divided by 1 minus 0.2 is 0.8 mx plus c. This is the value. This is the value which you want to compute, the value of y cap in our case. So always remember that this cost function, which we will discuss in the upcoming section of the video, you will observe it's dependent on the probability value. If you will try to solve this number, you will find that this number will be somehow negative. Just solve it out at your end. And that's why you will observe that the final output which we will be able to get as a class 0 or 1 per se, we will be able to get the final prediction as 0. Similarly, let's say I will say that, the probability is, let's say 0.8. Probability of, maybe you are saying that it's a 0.8. Sigma of y cap. So if it is confusing you, you can say sigma of y cap, which is the probability which is indicating, right? Because I have told you sigmoid function will only give you a probability. So if let's say it's a 0.8, then what will happen? Again, you will apply this equation 0.8 divided by 0.2, which is equals to again the value of y cap mx plus c. You will see this value will come out to be positive. And if it is positive, you are saying as a final prediction as class 1. So what you are doing here is you are trying to get that final prediction value y cap in case of a logistic regression with the help of this logarithmic formula. How we have computed? You can see its complete derivation. Simply, we have tried to apply the value of y cap in the entire equation, reach to a point where we have seen that if the probability is very less of any particular class, the number will be negative. Negative number indicates it belongs to class 0. If we are having a higher probability, the value will be positive. It indicates that the value will be, or the class will be 1. So that is how basically it is trying to solve the problem of a binary classification task in case of a logistic regression algorithm. So the entire process is based on how we are computing the probability. So always remember, if someone will tell you that, what is the functionality of a sigmoid function in logistic regression, your answer should always be it is giving me the probability of a class. Now, depending upon whether the probability is below threshold or above threshold, the value will be either 0 or 1, right? In case of a binary classification task. So it entirely depends on that threshold value. I hope it makes sense. So this is the overall idea behind the logistic regression. So now I hope that you clearly got the idea of, how linear regression basically works and at what point of time basically we should go for linear regression algorithm. In the upcoming video, we will talk about the cost function of linear regression. Again, a very important video because for an interview perspective also, many people usually ask this question and many students are usually confused regarding the cost function of logistic regression. So I will try to talk about everything in a great detail so that you will never forget, right? So with this, let's end today's video. I hope you have already enjoyed the complete video end to end. If you have any questions, any doubts, please feel free to reach out to me. You can connect with me via LinkedIn or via email. Bye-bye everyone and see you.